Chapter Polynomials and exercise 3.1. Here is question number 1a. If p of x is equal to 5x power 7 minus 6x power 5 plus 7x minus 6, then find the coefficient of x power 5, find the degree of p of x, and find the constant term. I shall repeat. If the polynomial p of x is equal to 5x power 7 minus 6x power 5 plus 7x minus 6, then find coefficient of x power 5 and the degree of the polynomial p of x and find the constant term. Here is the solution. We have given the polynomial 5x power 7 minus 6x power 5 plus 7x minus 6. Then we have to find the coefficient of x power 5. Here this is the x power 5 term, minus 6x power 5 is x power 5 term. Okay, this is the x power 5th term. Now in this, the coefficient means the value which is just before x, or the number which is multiplying x power 5 is called coefficient. This x power 5 is multiplied by minus 6. Therefore, minus 6 is called the coefficient of x power 5. X power 5 coefficient is minus 6. And the next is degree of the polynomial. We already learned what is a degree. Degree means the highest exponent of the variable. Here this variable x has exponent 7, here exponent 5, here exponent 1, and here it is a constant term x power 0, exponent is 0. Then what is the maximum value? Maximum value is 7, therefore degree of the polynomial is 7. And next the constant term. What is the constant term in the total given polynomial? Constant term means a term without variable. Here you can find variable, here also variable, here also you can find variable. But in minus 6, in this term there is no variable. The minus 6 is called the constant term of the polynomial. Now same question number 1 and debate. Write 3 more polynomials and create 3 questions for each of them. Write 3 more polynomials at our own and create 3 questions for each of them. We have to write 3 polynomials and we have to create 3 questions for each of the polynomial. Here is the solution. Let us write the first polynomial p of x is equal to x plus 1. It is a linear polynomial. Now we have to frame 3 questions for this polynomial p of x is equal to x plus 1. You can frame any type of questions. For example, find the degree of the polynomial p of x. That is the first question. And second question, find the 0 of the polynomial p of x is equal to x plus 1. And the third question, how many zeros can you find to the given polynomial p of x is equal to x plus 1 is the third question. We have to frame the questions only. We need not solve them. We need not find answers for those questions. He asked you to frame 3 questions for each polynomial. Here we took the first polynomial as p of x is equal to x plus 1. Then we framed the first question like find the degree of the polynomial p of x, and second question find the 0 of the polynomial p of x is equal to x plus 1, and third question how many zeros can you find to the given polynomial. Now we will frame another polynomial now. Second polynomial q of x is equal to x square minus 3x plus 2. In this case we took a quadratic polynomial. You can write any of the polynomial of any degree at your wish. Here I took a quadratic polynomial q of x is equal to x square minus 3x plus 2. And the first question I framed is find the degree of the polynomial q of x is equal to x square minus 3x plus 2. Here what is the degree? Good, the degree is 2. And the second question find the 0 of the polynomial q of x is equal to x square minus 3x plus 2. Here there may be 2 zeros since it is a quadratic polynomial. Either you may ask to find both the zeros or you may ask to find at least any one of the zero. And third question, how can you call a second degree polynomial? How can you call a second degree polynomial? You can call this as a quadratic polynomial. Good. Now question number 2. State which of the following statements are true and which are false and give reasons. I shall repeat. State which of the following statements are true and which are false. Give reasons. First bit. The degree of the polynomial root 2x square minus 3x plus 1 is root 2. Look at the question. The degree of the polynomial root 2x square minus 3x plus 1 is root 2. Look at the question. Minus root 2x square minus 3x plus 1. The degree is root 2. It is given. The degree means the highest exponent of the variable. Here the exponent of x is x square. In this term exponent of x is 1 and in this term exponent of x is 0. Then what is the maximum exponent? 2. Therefore the degree of the polynomial is 2 but not root 2. But what is root 2? Root 2 is multiplied by x square. Therefore root 2 is called quotient of x square. Okay. Therefore the solution is, it is false. The given statement is false. The degree of the given polynomial is 2 and the quotient of x square is root 2. Look at the second bit. The quotient of x square in the polynomial p of x is equal to 3x cube minus 4x square plus 5x plus 7 is 2. I shall repeat. The quotient of x square in the polynomial, x square term, you can find minus 4x square is x square term. This x square is multiplied by minus 4. Therefore, the value which is multiplied with x square is called quotient. Then here the quotient of x square is minus 4. But what is given? It is given that 2 in the question. Therefore, the given statement is again false. The quotient of x square in the polynomial is minus 4. And third bit. The degree of the constant term is 0. The degree of the constant term is 0. Take any constant term. We know that every constant term is a 0 polynomial and its degree is also 0. Therefore the solution is, it is true. The degree of any constant term is always 0. It is called 0 polynomial. Fourth bit. 1 by x square minus 5x plus 6 is a quadratic polynomial. If you look at the question, you can find 1 by x square minus 5x plus 6. This x square minus 5x plus 6 is in denominator place. If you take it to numerator, then the exponent may become negative. If the exponent of the variable is negative, then it is not a polynomial at all. When can you say that an expression is a polynomial? Only when the exponent of the variable should be a non-negative integer, means it may be either 0 or a positive integer. But in this case, here since the variable is in denominator place, the exponent may become negative, therefore which is not a non-negative integer and it is not a polynomial. Therefore the given statement is false. It is not a polynomial because exponent of x is not a non-negative integer. Fifth bit. The degree of the polynomial is 1 more than the number of terms in it. The degree of the polynomial is 1 more than the number of terms in it. Here please keep in mind, number of terms is always different from the degree. Degree means it is the highest exponent of the variable. It is different from the number of terms in the polynomial. There may be any number of terms in a polynomial. Number of terms is different from the degree of the polynomial. Then the solution is, the given statement is false because the degree of the polynomial is always the highest exponent of the variable. Now look at question number 3. If p of t is equal to t cube minus 1, then find the value of p of 1, p of minus 1, p of 0, p of 2 and p of minus 2. I shall repeat. If the polynomial in t, p of t is equal to t cube minus 1, then find the values of p of 1, p of minus 1, p of 0, p of 2 and p of minus 2. Here is the solution. We have given the polynomial which is p of t is equal to t cube minus 1. Now we have to find p of 1. In the place of t you can find 1 now. In the place of t you can find 1 now. Therefore in RHS also, in the place of t you substitute 1. Then 1 cube, t means 1 now, that is 1 cube minus 1. 1 cube is 1, minus 1, 1 minus 1 is 0. Next p of minus 1. In the place of t now you can find minus 1. Therefore, substitute in the place of t minus 1. Minus 1 whole cube minus 1. Minus 1 whole cube is minus 1 into minus 1 into minus 1, which is minus 1. Minus 1 is minus 2. Therefore, the value of p of minus 1 is minus 2. Next, p of 2 means in the place of t now substitute 2. 2 cube minus 1. 2 cube is 8. 8 minus 1 is 7. Next, p of minus 2. In the place of t now substitute minus 2. Minus 2 whole cube minus 1. Minus 2 whole cube is minus 8 minus 1. Minus 8 minus 1 is minus 9. Next, p of 0. Substitute t is equal to 0 now. 0 cube minus 1. 0 cube is 0 into 0 into 0 is 0. Minus 1 is minus 1. Therefore, these are the values of p of 1, p of minus 1, p of 0, p of 2 and p of minus 2. Like this, you can find these values. Therefore, you can write that p of 1 is equal to 0, p of minus 1 is equal to minus 2, p of 0 is equal to minus 1, p of 2 is equal to 7 and p of minus 2 is equal to minus 9. And the fourth question is also in the same model. You can do it very easy. You may please practice it. Now question number 5. Check whether 3 and minus 2 are the zeros of the polynomial p of x, where p of x is equal to x square minus x minus 6. I shall repeat. Check whether 3 and minus 2 are the zeros of the given polynomial p of x, when p of x is equal to x square minus x minus 6. Here we have to find out whether 3 is a 0 of this polynomial, and we have to check out whether minus 2 is a 0 of this polynomial. When can you say that this 3 is 0 of this polynomial? If we substitute x is equal to 3 and you get finally the value of the polynomial is 0, then you can say that 3 is 0 of this polynomial. Similarly, when can you say that minus 2 is 0 of the polynomial? If we substitute x is equal to minus 2 and if you simplify this value and you get finally 0, then you can say that minus 2 is also 0 of the polynomial. But in the place of x, if you substitute x is equal to 3 or x is equal to minus 2 and you did not get the total value of the polynomial is not 0, not equal to 0, in such case you cannot say that 3 and minus 2 are zeros, or in other words you can say that 3 and minus 2 are not zeros. Therefore, in order to check out whether 3 and minus 2 are zeros of this polynomial, let us first of all substitute x is equal to 3. Let us substitute x is equal to 3 in the polynomial and let us find its value. You see here, given polynomial is p of x is equal to x square minus x minus 6. Now let us find the value of p of 3. P of 3 means 3 square minus x means 3 minus 6. 3 square means 3 into 3 is 9. Minus 3 minus 6. This is plus 9. Minus 3 minus 6 is minus 9. What is 9 minus 9? 9 minus 9 is 0. Therefore, in the given polynomial, if we substitute x is equal to 3, we got the value of the polynomial 0. And in the second case, let us substitute x is equal to minus 2. Then p of minus 2 is equal to minus 2 whole square minus x means minus 2 and minus 6. Minus 2 whole square is plus 4. Minus of minus 2 is plus 2 and this is minus 6. What is 4 plus 2? 4 plus 2 is 6 minus 6 and it is also 0. Therefore, in the place of variable x, if we substitute 3 and minus 2, we got the value of the polynomial 0 in both the cases. Since the value of the polynomial is 0 for these two values, these values are called zeros of the polynomials. Since p of 3 is equal to 0 and p of minus 2 is equal to 0, 3 and minus 2 are zeros of the polynomials. By this, we concluded the exercise 3.1. You can find the links of chapter 1 and chapter 2 videos in the description. You can click the links to revise those chapters. Thank you, Ananda.